Welcome to this lecture for the theory of error, where I will introduce you to the subject. So, myself, Pankaj Singh Kalam. So, this subject I have created out of the curiosity and also when I was learning, just to remember. So, these lectures are if you want to learn. So, if you are a student of surveying and you want to learn the surveying, theory of error is one of the subject or module that is also required you to understand, that is also required that you should learn about theory of error. So this is an introductory lecture, so I will just in a brief tell you about the subject and its importance, and in the subsequent lectures or the videos I will tell you each and every concept in detail, and after that example theories I will also try to show you some examples, so that how actually you can utilize, or how actually you can use this theory of error for the actual computation and adjustment. So let us begin this introductory lecture for the theory of error, and my reference books are, I'm referring actually two books here to prepare this lecture. I will, in the end, I will give the name of those books. Those you can refer those books. So let us move on to the next slide. So in this introduction to the theory of error, I will just try to tell you in a very brief that what is theory of error and why you should learn this. How can you use this knowledge into the surveying? So what is theory of error? In this theory of error, in the subject name itself, you can see here is error. So in a surveying, basically what we do. So if you want to survey a point, let's say this is a point where you want to locate this point. So you locate this point with respect to some points, let's say point B and the point C, by measuring the distance between the CA and also the distance between A and B. So surveying is all about measuring. So when you go for the surveying, you measure, and whenever you measure or when you repeat the measurement, there will be error. It is a very natural phenomena that we will see in the subsequent slides or the lectures, that error is a very natural phenomena. You cannot eliminate it. How whatsoever you do, even you get the best instrument, get the best man, even when you repeat the measurement, there will certainly be error. The reasons and the details we will see in the subsequent lectures. So now it is certain that whenever you measure, there is an error. Due to this error, how actually you will finalize the value between, how you will actually finalize the value of a physical quantity. For example, here that a distance between A and B is a physical quantity. So if you measure it at twice, what distance actually you will consider? Let's say in the first attempt you get the distance 2.1 meter, in the second attempt you get the distance 2.2 meter. What distance actually you will finalize? What you will say the distance between A and B is 2.1 or the 2.2, because this variation is occurring due to the error. So this kind of a questions arises when you do the measurement. How you will actually finalize the value of a physical quantity, how you will actually compute it and adjust it, how will compute and adjust, and this adjustment should be based on some basic principle or rules. Okay. So theory of error actually gives you the answer to all these questions. This type of questions in the surveying actually deal by this theory of error. Okay. So now the second point, why should I learn this? So if you are doing any survey measurement work, so how you will actually finally compute the data, how you will actually represent the final distances and the data what you have measured, because you are measuring it twice, thrice, or the multiple times, but you're getting a different value. Even you are, in case of the traverse, you get some closing error. How actually you will adjust all these closing errors, and different examples we will see in a detail. So if you don't know about the theory of error, if you don't know about the error, how you will actually finally compute and adjust? Maybe you compute and you were computing and adjusting, but you are not very aware of the basic core principle how you are actually doing this. Okay, maybe the software is doing this for you and you are not aware of the theory. So here we actually will see the basic theories, basic concepts behind this, how actually you compute and adjust the final values. So that's why in this manner I think you should, and everyone who is very curious about the surveying and all that final values, how they actually come, so they should learn this subject. How can I use this subject knowledge in the surveying? When you actually have a very good knowledge of, or even the basic knowledge about the errors and how actually we see the errors in the surveying, how we actually adjust them. So this knowledge actually will give you, you can apply, for example, first in any project design. If you design a project for the survey, there will be a basic questions first. Let's say, what would be the final accuracy of your survey work? Okay, it can be in terms of positional accuracies, let's say xy, and maybe in some project where height is required z. So you will fix a requirement of this project finally, that you want this kind of accuracy, positional accuracy, and this kind of a vertical accuracy. So based on that, you need to adopt some kind of approach, some kind of a standard procedures and instrument which will actually give you this final result. So you can pre-analysis, that we will deal in subsequent lectures. There is a pre-analysis, you can do the pre-analysis based on this theory of error, and can get what and you can actually assess the requirement, initial requirements of your instrument, your procedures, how how you will actually go, what procedures you will adopt to finally get this your project output, quality and your project output specification. To achieve a specification, you do the pre-analysis, so that at the initial stages only you will decide what should be the standard operating procedures while you do the survey, what instruments you can use, how many times of you need to repeat the measurements. This kind of a questions can be answered by theory of error. Also, when you have the error, finally how you can deal with it, this knowledge can be applied. And in a way, if you know this, and this is my personal intuition or the opinion, that if you know that the theory of error, so you will actually have a very good understanding while you actually project your requirement also. Okay, let's say if you say that you want the final accuracy of your GIS map 10 centimeter, so that is your final accuracy, but that would not happen each and every time. There may be a times when you check the area and your at some point your accuracy may be the 10.2 centimeter. So whether you will accept this or not, or you will say it is rejected. So we do not talk in these terms that the 10.2 centimeter we will reject. It's some kind of a 95% confidence you might have heard if you are a survey professional. So in that way you actually talk about this final acceptance test and all that. So even if you want to do the QA/QC, this knowledge of any GIS product, this knowledge of theory of error can be used here. So in this way you can there is a lot of application of this subject knowledge that you can actually use, that you can actually apply this knowledge for this kind of a purposes and many more. So this was just the introductory lecture, where I actually tried to give you some outline that what subject really is, in a subject what things actually we are dealing with. So basically we are dealing with the errors in the measurement, so that finally we can have some final computed and adjusted values that fits the overall, you can say, the geometry, the system, or that fits the bill, so that we can take those values after correction. And once you know this overall theory of error and you understand how things are working in the surveying, so that knowledge can be applied to assess the requirement of a project to achieve some final specified goals. Okay, and so you can do in a surveying project design, you can use this knowledge. If you have some errors during your measurements, how you will adjust, that knowledge can be applied in that. Okay, and QoQC of a GIS product. If you have some GIS product already, let's say you have some GIS map, maybe you have some imagery, and you want to know the positional accuracy of this GIS product imagery, how you will actually do the QAQC. This knowledge can be applied, and overall, at the end of this subject knowledge, you will be able to talk in terms where you will sound relevant, or you will sound logical in terms that example 10 centimeter, actually that your final project requirement is that, but you, when you will check, definitely there will be a variation. So up to what limit variations will be, you will accept, like 95% of the time you will accept with some kind, okay, and the 5% it can vary. So in that case also you will accept that final product. So all this we will deal during this lecture series in detail, and also with some examples, and we will give, I will try to give you here some example and solution to that example, and also I will try to include the live practical example. I will try to connect this theory with the examples of surveying, that or the procedures that actually we do to connect with the theory. Let's say if I'm saying this theory, like the theory is that, so I will try to give you some practical examples that where we are actually applying this theory knowledge. So I hope we'll meet in the next lecture. If you like, please continue watching this lecture, and if you have some kind of a suggestions, or is there some mistakes, just point out in the comment section. So these are mainly two books that I am referring for my understanding and even to prepare this lecture. You can also refer all these same books, these two books, and also there are so many literatures and materials also available. And the experience what I will try to share is based on my working knowledge in the Survey of India. Okay, we'll meet in the next lecture.